Hello, today we will study the quantum mechanics. Quantum mechanics is actually very difficult subject. Even Einstein was very panicked to understand this. There was a lot of concepts, a lot of controversies there. Okay, I will try my best that each or every one you will understand this. First of all, we will understand the classifications of quantum physics. Uh, Quantum is of two types, or I can say the study belongs to two types. First is we have the classical quantum, or I can say classical concepts, and another one is called quantum concepts. Quantum mechanism and classical mechanism and quantum mechanism. If we will discuss about classical mechanism, then the two things, one is M and another one is P. There we have, or we can X and P. If we know the position, if we know the position and the momentum, if we know the position and momentum, then we can find anything or any type of energy or any physical quantity which is related to classical mechanism. As I say, we can find energy, or we can find kinetic energy, we can find potential energy, or else we can find that type of mechanism, or we can that type of quantities which are related to this mechanism. Okay, but this quantum mechanism is actually further different from the classical mechanism. Now we will understood that what is the difference between classical and quantum mechanism. Here we will study about a person whose name is Heisenberg uncertainty principle, who says that delta x dot delta p is greater than h upon 4 pi. I strongly recommend you, please see this. What is Heisenberg uncertainty principle? If we will know the full explanation or the full theory of Heisenberg uncertainty principle, then half of the quantum is completed. In this section, I further said that quantum is most difficult one, but the basic one you can know. There we have two rules. According to me, there we have two rules. Rule 1 and rule 2. The rule 1 is there we have psi. There we have a psi. This psi is a complex number. First, you will have basic some. You will have a little bit of knowledge of mathematics. Okay, you will have to know what is the meaning of complex number. In the complex number, there are a real number or an imaginary number. Okay, so this psi is an imaginary is a complex number. Okay, oh, and so we can write psi is directly proportional to c. It's a complex number. Okay, it's directly proportional to the c. So as we know, as in the second rule, if we will scale this psi, if we will scale this psi, then it will equal to the probability. It will equal to the probability. Now what I want to say with this, that this is equal to the probability. In the other sense, I want to say that if psi is a complex number, okay, if psi is a complex number, and if we will scale the complex number or the imaginary number, then we will get the real number. Then in this we will get the real number. As we say, iota is multiply iota, and we get the real number. Now the only thing we will have to know is if psi is a complex number, and we will have to multiply it, or we will have to square root. We will square root it, and what we will get, we will get the real number. Okay, and we further said it the probability. Now the actual thing is, in this complex, Let me see what the Heisenberg principle said. He said that it is not possible to measure simultaneously both position and momentum of a microscopic particles with a absolute accuracy. So we can find momentum or we can find position. Okay, first we see if we have a probability of x, it means the probability of that compound is psi square, as I say that px is equal to psi square. Now I will draw something for you. Let's see this or this. Now understand this. This is psi 1 as we assume, and this is psi 2 as considered B. Now if I want to find the probability of the psi 1, now I will scale this psi 1. Okay, then we will find the probability. So if I will scale this psi 1, then it will become double, and here it's also gonna double. Now the thing is, now we accurately know that in this manner, in this position, these are the position where is the probability to find the electron. It means the position of electron, the probability of position of electron is fixed. Now we have the probability of finding the electron. Now in this sense we can find the probability, but what about the momentum? Now if I say about momentum, as we know about about de Broglie principle. According to de Broglie principle, lambda is equal to h upon mv, or we can say mv is equal to p. So I can write delta lambda is equal to h upon p, and p is equal to h upon lambda. I can also write it like this, that p is equal to h upon lambda. It means momentum is equal to h upon lambda. I can write like this. So the actual thing is, if I got the lambda, or I can say if I have the wave function, if I have the wave function, and as we know this is h is called Planck constant, and Planck constant we have 8.8 into 10 to the power minus 34, as we know. If we got wave number, then we can find the momentum. But there is another formula we will have to know. Lambda is equal to, or we can say, what is this wave function? Now as we know, this is crust, trough and crust. The difference between the crust to crust is represented as lambda, or the wave function. Okay. Now the formula of this is E minus I kx. Sorry, it's a positive I kx. Okay. Now if we have to find the probability, of this side, so we will have to scale it. But as accordance with the math, if we will scale it, then it will become E minus I kx. This, the value of this crust, rough crust, is e to the power I kx, and if we want to find the probability of this, we will multiply it with e to the power minus I kx. Then the value will be e to the power 0. It means 1. The value will be 1. Now, what we got, the probability graph will be like this, because the probability is 1. So it will as like this, as a horizontal. Now we will have to find that where is the position of the particle, where is the position of the electron. Now anywhere, the position of the electron is anywhere under this line, anywhere. Now this line is going to the infinity position. So how would I know that where is my electron? So I couldn't find x. It means I couldn't find the position of the electron in this section. Okay. But if I want to know the momentum, then yes, it is possible. Momentum, the finding of momentum is possible, but position, the finding of position is not possible. Okay. Now the next thing is, but if I have this, if I have this Simon, and the probability, we say this is the probability, double the Simon, then we can find the x, we can find the position, but there is no one another crust to find the lambda. There is no other crust to, because if we want to find the wave function, then we will have to we must have the two crusts. So the difference between these two crusts will be the wave function, but there is just one crust. There is just one graph. So it will definitely find the x, but not find the, we could not find the momentum. But in the other sense, if we have the graph, if we have crust of crust, then we can find the lambda. We can find the lambda, but we couldn't find the position of that. This is the basic principle of Heisenberg principle, that it is not possible to measure simultaneously both position and momentum of a microscopic particles with the absolute accuracy. So that's the first criteria. Now in the second video, I will show you some of the numerical or some of the theoretical manner, because this is the experimental manner. But with the help of this formula, I will show you some of the aspect that will define the theoretical manner.